You're welcome to my series, Best Helping Hand for JAMB Students. Please, if you have not subscribed to my YouTube channel, please subscribe to encourage us in this good work. If you are just new in this series, a lot of videos has been released, and I will advise you to please go back and watch the previous video. In case you have a question you want to ask, please ask the question on the board or direct it to me on my WhatsApp using the WhatsApp number at the end of the video. Definition of work. What is work? Work is said to be done when a force is applied to an object and the object moves in the direction of the force. Work is said to be done when a force is applied to an object and that object moves in the direction of the force. So, what is not work? Work is not done if you apply force to an object and that object did not move. So, we say work is done when you apply force to an object and that object moves in the direction of the force. So, irrespective of the force you are applying to an object, no matter how much it is, as long the object did not move, it is not work. That is what I mean by what is not work. So, what is work? Work is said to be done when a force is applied to an object and the object moves in the direction of the force. Welcome to my series, JAMB Helping Hand. The best helping hand for JAMB students who want to write JAMB. And by the grace of God, with the help of this tutorial, you will see yourself in flying colors. It is a summary note on the things that you are supposed to have learned in your secondary school days, covering the curriculum for JAMB. So, in this lesson, we'll be talking about work, energy, and power. What is work? Work is said to be done when a force is applied to an object and this object moves in the direction of the force. Force F is applied to this object and this object moves in this direction. So, when is for work said to be done? Work is said to be done when a force is applied to an object and this is the object. This object moves in the direction of the force. Then we say the work done is equals to force multiplied by distance moved. So, back to business. What about if the force which is being applied to this object is not straight? Let's assume that we have the object like this and we apply a force to it in this direction. Look at our force. What is it? If it moves horizontal distance of A, it moves horizontal distance of A and it makes this angle theta with the horizontal, we will say that our work done in this case is equals to force multiplied by the distance moved, which is A, cos theta. Theta as the angle between the horizontal and the force. Angle between the horizontal which moves force. So I have diagram 1 explaining work, diagram 2 explaining work. So I want to have diagram 3 which shows a load and we have a force applied to it, and this force is force F, inclined to vertical phi and it moves a distance b in the horizontal direction. So what is the work? What calculates the work done in this case? The work done in this case is equals to force multiplied by distance moved b, then you have sine theta. So it's sine theta if you are given angle which it makes with the vertical, cos theta if you are given the angle which the force makes with the horizontal. So please don't misinterchange them. These are the type of logical question JAMB can ask you. They will draw a diagram for you showing you that is inclined at either to the horizontal or to the vertical. So if it is to the horizontal, you have f multiplied by distance cos theta. If it is inclined at vertical, is f multiplied by the distance sine theta. So then the next thing is, what is not work? Work is not done. If you apply a force to an object and that object did not move, irrespective of the amount of forces or force you are applying on the object, as long that the object did not move, it means no work is done. As long as the object did not move, it means no work is done. Reason why did we say the no work is done, or why do we say the work done is 0? Remember that work done is equals to force multiplied by distance moved. So when the distance moved is equals to 0, it means force multiplied by 0, which makes it is 0. So I believe we have seen a question with that. The next thing we'll be talking about is take some example on this. Example 1. A boy of weight 500 Newton climbs the top of a hill. Climbs the top of height 20 meter. Calculate the work done against the force of gravity is dash. So then you will be given options to the question. You'll be given options to the question. So how do we calculate this? Force, that is the weight of the boy. The boy needs to overcome his weight, carrying it to climb to a height. So we say the weight of the boy in this case is the force. So force multiplied by distance in the direction we are talking about, distance, which is equals to 500 multiplied by 20, which is equals to 10,000 joules. So 10,000 joules, and we can write it as what? 10 kilojoules, which is equals to 10 kilojoules. So then we move to another example. This example has to do with what we call force displacement diagram. These are one of the very tricky questions that you can see. Force displacement diagram. So in force displacement diagram, here we have force and here we have displacement. So, and this is question 1, this is question 2. So in force displacement diagram, we are being asked to find the work done by a body. Work done by a body is equals to area under the graph. So area under the graph. So please don't forget, when you're asked to find the work done, then we'll say the work done is equals to area under the graph. Work done is area under the graph of force displacement diagram. So if we have a shape like trapezium that they give like this, have a shape like trapezium. Here is 0, here we have 10, here we have 20, and here we have 50. So find the work done in this case. The work done is equals to the area under this graph. We have to calculate the area under this graph. So the area under this graph, this is a trapezium. So area, which is equals to work done, will be equals to A plus B divided by 2 multiplied by height, which is equals to A 10 plus 20 all over 2 multiplied by 50. So which is equals to 30 over 2 multiplied by 50. So what do we have? So we have here 15 times 50. 15 times 50 is equals to 750. 750 joules. The last example I would love to take is still on force displacement diagram. Calculate the work done by a system whose force displacement diagram is shown below. So in this case, look at what the question look like. Force displacement, force in Newton, displacement in meter, and I have 20 Newton here, I have 20 meter here. So it forms a quadrant, forming a quadrant displacement in meter. So calculate the work done. The work done in this case is very simple. So all we need to do is calculate the area under this graph. The area under this graph is what? Area force work done is equals to area under the graph. So area under the graph. So how do we solve for that? We'll find the area of the circle and divide it by 4, which is equals to area of quadrant. Area of circle divided by 4 So which is equals to pi r square all over 4, which is equals to pi multiplied by r, which is equals to 20 times 20 divided by 4, which is equals to 400 pi over 4, which is equals to 100 pi. So in this case, the work done is equals to 100 pi joules. So thank you for watching. Please, if you have not subscribed to my YouTube channel, please do, because I still have many more topics to teach you or to still explain and simplify them to you. Don't forget what we have done in this class. In this class, I've quickly reminded you of what is work. Work is said to be done when force is applied to an object and the object moves in the direction of the force. I gave you the formula how to calculate when it is a force parallel to the displacement. I gave you when the force is inclined and we are given the angle which it makes with the horizontal, we make use of FA cos theta. If the force is inclined to the direction of movement of the body, then we have work to be equals to F multiplied by displacement sine theta. Then I also gave you the formula, or reminded you of the formula, that the work done is equals to area under the displacement force displacement graph, the area under the force displacement graph. And we solved just 3 examples in this lesson. So in the subsequent class, we'll be talking about energy. So, till we meet then, thank you.